So we're going to tackle the proving that two triangles are congruent and proving statements of triangle congruence. So we have to remember the past, the congruence postulates. So before we discussed about the SS correspondence or the SS postulates, the angle side angle correspondence or angle side angle postulates, side angle side. And the new one is the angle angle sides. Okay, remember there's no side side angle or AAA or angle angle angle. So that's why it says cross. It's not included in the postulates. So this is the figure of the angle, 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 but this is not included to the postulates, the triangle congruency postulates. So as you can see, we have this angle, since we have angles and angles. So there's no sides, so this is angle, angle, angle. Again, this is cross because it's not included. Next, the angle, side angle. So this is the figure of angle, side, angle. And the next one is the side angle side. So I show you the vertical angles. When you say vertical angles, we have the common vertex. And this is the side angle side. So that is a figure of side angle side, which is vertical angles. The next one is side angle side, which is not vertical angles. So the two triangles are separated. So this one next is the reflexive property, but this is side angle side. So when you say reflexive properties, it's reflect. So it's like the mirror when you face the mirror, so you see your figure, your face, and your body. So this is reflexive property. And this is a reflexive property also, but in the congruence postulates, that's not uh, included because this is side angles. So look at this one, side have this one here, side, side angle. So that's not included. So again, the cross here is not included, the congruence postulate. We have the three types of mathematical proofs. So let's have the number one. This is two-column proofs. A two-column proof is one common way to organize a proof in geometry. Two-column proofs always have two columns, one for statements and one for reasons. So we have the statements. When writing two-column proof, we have to keep things in mind. The first one starts with the given informations. Then statements with the same reason can be combined in one step is up to you. Then draw a picture and mark it with the given informations. You must have reason for every statement. The order of the statements in the proof is not always fixed, but make sure the order makes logical sense. Reasons will be definitions, postulates, properties, and previously proven theorems. Given is only used as a reason if the information in the statement column was a given in the problem. Yeah, just use symbols and abbreviation for words within proofs. For example, this congruent can be used in the place of the word congruent. You could also use the angle for the word angle. This is the example of the two-column proof. So we have the given lines M and N intersect. Angle 1 and angle 3 are vertical angles. So we have to prove M angle 1 equals to M angle 3. So we have this one, the statements, and the other one is the reasons. Then we have the lines M and N intersect. Angle 1, angle 2 are vertical angles. So that's a given. Then angle 1 and angle 2 linear pair, and angle 3 and angle 2 are linear pair. So this definition is of linear pair. Then M angle 1 plus M angle 2, that's equals to 180 degrees. And M angle 3 plus M angle 2 is equals to 180 degrees. So this is the angle 3 and angle 2, 180 degrees. And angle 1 and 2 is 180 degrees. Just because we need to prove that angle 1 is equals to angle 3. So this is the definition of supplementary angles. And next, we have the m angle 1 plus m angle 2 equals m angle 3 plus m angle 2. So we use this as substitutions. Why is it substitutions? So this is the angle 1 and angle 2, and we have the angle 3 and angle 2. So it's just same with the angle 1 and angle 2, just by substitutions. And now, the angle 1 is equals to m angle 3. So this is the final, the subtraction property of equality. Alright, so let's have the example number two. The side angle side postulates. So given is N is the midpoint of line segment W, then N is the midpoint of line segment SK. So we have to prove that VL and S congruent to VW and K. So it's something is difficult to analyze, but we have to prove the side angle side postulate. Now let's have first one the statement and reasons. So N is the midpoint of LW and N is the midpoint of SK. So or line segments SK, line segments LW. So this is also a given. So take note we're going to start from the given. And then line segment LN is congruent to line segment NW or line segment SN congruent to line segment MK. So this is the LN and this is NW, this is congruent. Then the SN and NK is also congruent. So this is called the definitions of midpoint. And then we know the midpoint is the middle of the one, right? Then angle L and S congruent to angle W and K. So this congruency of the angles is definitions of vertical angles are congruence, like we did for the RTP or the remember the past. And then we have the VL and S congruent to VW and K. So this is the final, the side angle side possibly. This is the another one proof in the mathematical equations system. Paragraph proofs. A proof can be written in the paragraph form. The then statements and reasons in the paragraph proof are written in sentences, using words to explain the logical flow of the arguments. So let's have this one. Refer to the diagram shown AR equals to CR and VR equals to VR. Write a paragraph proof to show that AR plus DR equals CR plus DR. And this is the figures. So given the AR equals blank and JR, so we're going to find out. So this is the AR. So AR is congruent or equal to CR. So that's the answer. And DR here, the DR is here in the figures, and then this is the PR. So it means that's the answer. So we're going to prove that blank equals to CR plus BR. Prove you know that AR equals CR and DR equals PR. AR plus DR equals to CR plus DR by the blank. So we have to get the answer here. So since we have the key here, the CR and the BR, now the answer is AR plus DR. So this one. Alright, so this is what kind of property of equality by additions. So we use the additions here. And then for AR plus CR equals CR plus VR. So what happens? This is substitutions. So why is it substitution? So AR plus CR is CR BR. So if we're going to substitute, this is same with the congruent size. So that's the substitution. Now let's have the flowchart proof. The flowchart proof is not usually used for the proving statements. So this is a proof connected with arrows. This is example. It's like that. So you can skip it because it's not sometimes it's not usable to this one. Okay, let's have the try this. So we have this given the line segment GJ and line segment HK bisect each other at F. So here. Now we have to prove that triangle GFK is congruent to triangle HFJ. So again, let's have the statement and the reasons. The first one is line segment GJ and line segment HK bisect each other at F. So this is also given. Again, to start from the given. Then next we have the line segment GF congruent to GF. So GF congruent to JF. And for another one is KF congruent to HF. So this is called the definitions of bisector or the definition of bisect. So next we have the angle GFK congruent to angle HFJ. So this is the vertical angles. The vertical angles, we have the common vertex here. Alright, and then for triangle GFT congruent to triangle HFG, so this is side angle side. So it's just we know that the side angle side is the final answer for this proving the triangle GFT congruent to triangle HFG.